Okay, this is the page 2 from the Unit 6 retest review. On this first example, the problem that you're facing here is that you're going to have this problem point because when you divide by 0, that's an issue. And if you'll notice the bounds of my integral, 0 is included in there. That's what makes this an improper integral, and that's why it's a problem. So you'll see I kind of wrote it as like problem point at x equals 0, right? So that tells me that I need to break up this integral. So to break it up, you're just going to write it as the integral. We're going to say -2 to 0 because that's the problem point. You just break it up at the problem point. And I'm just going to rewrite this because I know I'm going to be integrating. So instead of having it as 1 over x to the 4th, just rewrite it as x to the -4th dx. And plus, now I have to do the other part of the integral. It'll go from 0 to 3, and that'll be x to the -4th again. So that's me kind of avoiding that problem point of 0, okay? And from there, now I can just take it as the limit. So those of you that kind of struggled with this test the first time, you might be like, oh, now you've actually practiced doing these improper integrals a little bit more, so it might be easier. So remember, with an improper integral, we were able to get away with certain things in the sequences and series unit because we were just dealing with that positive subset of integers. So this time, we are going to have to call it a. We're going to take the limit from -2 to a, because that's the problem point, of x to the -4th dx plus the limit as a approaches 0. Oh, we'll call it b this time. We'll say b approaches 0 from b to 3, and we'll write it like this. Okay? All right, so from there, now we are just going to integrate. So integrating this should be relatively easy. We're adding 1 to the exponent, dividing by that number. And I'm quickly seeing that I did not give myself enough room for this at all. So, sorry. The limit as a approaches 0. So if you add 1 to the exponent, divide by that number, you get to there. And we're evaluating at that -2 to a. And then plus the limit as b approaches 0. And then when I integrate this, it's going to be the same thing. Add 1 to the exponent, divide by that number, and I'm evaluating that at b and 3. Okay, so now you might want to take another line of work to rewrite this. I don't like it with this -3 as the exponent, so I would probably rewrite that as the limit a approaches 0, and I would probably rewrite it as -1 over 3x cubed, because to me that makes it easier to plug in. Some of you can do that all in your head, but I think it makes it a little easier when you rewrite it. Plus the limit as b approaches 0, and I'm just going to rewrite that one too as -1 over 3x cubed, and I'm evaluating that from b to 3. Okay. So from here, you're just plugging in. All you're going to do is you're plugging in. Well, fundamental theorem of calculus says when I plug in an a here, right, so it's still the limit. I didn't take the limit yet, so I'm still recopying that limit down. And when I plug in a, I'm going to get -1 over 3a cubed minus, because that's the fundamental theorem of calculus. Oh, and I'm running off the page. Sorry. When I do, oh, now I'm plugging in -2. Careful, -2 cubed, right? So that's going to be a -8. -8 times 3 is 24. Oh, so sorry. So you've got that 24, but it's going to be negative there, so that's going to end up, oh, it'll still be negative, right? Because you have this -1 divided by a -24, which is positive, but this is a minus. So we've got that, and plus, then I got to do the other side, the limit as b approaches 0. And when I plug in a 3 there, 3 cubed, 27 times 3 is 81. Probably didn't mean for these numbers to get quite that big, but that's okay. Plus, oh, well, it'd be minus, but when I plug in a b there, it'll be a negative. So minus a negative turns to a plus, and it'll be 1 over 3b cubed, and we'll close that up, okay? So now you're just taking the limit when you're doing zeros. So this should be kind of the review, because now you've been practicing doing this part in the sequences and series. So when you go to plug in 0 here, you get a number divided by 0. That's bad news. We can't divide by 0. So what does this piece do? That's going to go, that's bad. The whole thing's going to diverge now because of that piece. So like this piece goes to negative 24 when you plug in 0 because there's no variable there. This piece goes to negative 81, again, no variable. But these two pieces, when you plug in 0, they're going to infinity or negative infinity. So that's going to be a big yeah, because you're dividing by 0, so that whole thing's going to diverge. So you're going to have like a negative infinity. You can write it out like this. You don't even need to, though, because this whole thing is going to diverge because you're dividing by 0 there. So this whole thing diverges. Remember, whenever you see that infinity, that's a big clue that you're diverging there. Now, if I was plugging in an infinity, right, a number divided by infinity is 0. But a number divided by 0, that's a problem. That whole thing's going to diverge. Okay? All right, let's take a look then. I'm just trying to save some room. Let's skip to D. We'll skip to D just to save some space there, because I know some of you probably trickled over into there. Maybe I... Okay. We'll do this one, and then we'll talk about another. All right, so this one is going to be an example of using integration by parts. So remember, u dv, when you're trying to integrate u dv, that's going to equal uv minus the integration of v du. Okay, so now we just need to figure out what the u and the dv are. In this case, I usually let my u be the x thing unless when? When's the only time that your u's not the x thing? Do you remember? When you have an ln. Yeah, so normally let your u be the x thing, you know, whether it's a 2x or whatever. Here, it's going to be x squared. So u equals x squared. dv is the other thing. All right, so once you have the u and the dv decided, then you can go ahead and figure out what du is. So that's a 2x dx. Oh, technically I have a dx up here too. In v. When you're integrating e to the negative x, remember the integration of e to the x is still you recopy it. But the trick here is, remember, it's almost like 1 over the derivative of that on the outside. So you are going to have a negative out there. If you're not sure on that, technically you could do a u substitution on this, but I think that's, you know, most of you can just look at this v and then say, all right, well, if I took the derivative of this, you recopy it, times the derivative of the exponent, that would get rid of that negative there. So you don't, I mean, if you needed to do a u substitution off to the side, you could, but hopefully you're at the point where you can kind of skip that. Okay, so now that I have my integration by parts set up, I'm just going to kind of plug it in. So we're going to say that this equals uv. So I'm taking this u in the v, so it's going to be negative x squared e to the negative x, okay, and it's going to be plus, I left myself a little space here because, right, I'm going to have to evaluate this as a definite integral, so I am going to evaluate that there, but it's actually minus the integration of v du, but my v is negative, so instead of a minus, I'm writing it as a plus, and so that's this, and then du, so you can write that, I'm actually going to take that 2 out front too, so it'll be plus 2, the integration, and it's still from 0 to 1, and then what'll be left is e, or xe to the negative x, so I took the negative out, and I took the 2 from over here, and I just pulled it out in front of the integral to save a step. And, of course, that's with respect to x. So now you're left with just integrating this. What's the bad news about that piece? You have to use integration by parts again, okay? because that's two things multiplied by each other again. So I'm just going to do my next integration by parts off to the side here. Again, u is x, and that means that the dv is going to be e to the negative x. du equals 1 dx, and technically there's dx up there too. Okay, this is good news. Once your du is down to just a dx, that means that it's probably going to be the last time you have to do it, because everything's going to, you know, when you get back to this part in the next step, you're only going to have an e to the x, which will be good. And again, very similar to before, it's going to be a negative e to the negative x there. And now I can set up, I'm going to kind of drop it right in there. So this equals, I'm going to recopy everything to there, right? And then I have to start another one. So, I could plug in if I wanted. I could plug in this part to kind of clean it up. If you plug in a 1 there, you're going to get 1 squared is 1, but it'll be negative. So negative 1 e to the negative 1. So negative 1 e to the negative 1 minus, and then what do you get when you plug in 0? Well, anything raised to the 0 is 1, times 0 is still 0, so it's minus 0. That'll actually cleans up nicely. And then plus 2, and then I'm going to put it in brackets here. Now I'm ready to do this integration by parts over there. So for that integration by parts, it's going to be uv, so that'll be negative x e to the negative x, and I'm evaluating that from 0 to 1, minus the integration of v to u. Well, minus the integration, that's already a minus, so it's going to be a plus again. Integration from 0 to 1 of v, that's this, du. So it's just, I already factored the negative out, so it's like that. And now I can kind of start cleaning up here. So when this is a negative exponent, that means it's going to be underneath. So you have negative 1 over e, minus 0 goes away, and then it's plus 2. Plug in, so you have negative 1 e to the negative 1 again, and then the minus 0, that whole thing goes away. And now to integrate e to the negative x, we've already done that a bunch of times. When you integrate that, it's minus e to the negative x. And technically we need to evaluate that at 0 and 1, 2. And from here, you're just plugging in. You've just got a couple more lines of work. Yeah, I have no idea how I expected you to fit this in that little blank. Sorry about that. You might need some scratch paper for this. So you end up with negative 1 over e. You still have 2, or plus 2. That 0 goes away, and again, it's going to be that same thing, negative 1 over e. And when you evaluate that, it'll be plus. When you plug in a 1 there, negative e to the negative 1. Minus 1. That's the one that people mess up on a lot, is this one. When you plug in a 0, you get 1. Alright, oh, and so there. Alright. This one here is actually going to be a plus over there, because when you plugged in a 0, you got minus 1, but it's minus a negative turns to a plus there. So you can kind of clean this up one last time. You're going to get this minus that again, plus 1. So you're getting closer to the final answer. You have 2 of these, so minus 2 over e plus 1. Distribute your 2. Oh, that's an e. Minus 4 over e plus 2. And those two combine, negative 5 over e plus 2. And that is a couple from page 2.